Welcome. So this is a short-range communication technology ideology, which deals with real-world deployments, such as protocol deployment. So in real-world deployment, we have real-time problems, and these real-time problems gives more suggestions on how to deal with protocols, internet facilities, and other technical steps. So why short range matters in IoE? So the short range actually connects with billions of everyday objects that make up Internet of Everything. That is sensors, wearables, tags, and applications inside a home, inside a factory floor, or a few centimeters of radar. Okay. So here we have different ideas that are connected together to create ultra low short range communication protocol. And in that ultra low short range communication protocol, we deal with cell batteries, and those cell batteries have a concern of finding out some critical things for battery constrained endpoints. And so these battery constrained endpoints create some low value of power to hold on with, and that is a critical battery constraint. And inherent security, that is ultimate range, naturally reduces the attack of some surface for waves dropping and intercepting. That is inherent security services that creates more rapid portfolio in this, and followed by dense deployment. That is thousands of nodes can coexist in a single building. That is via a mesh or a star topology, and those mesh or star topology will develop a quick betterment in things that suggest more periodic wave of information. So the periodicity increases, and the dense deployment is being created to deploy across and create a strong mode of connectivity. That mode behaves more generic, and it creates star mesh topology connectivity, and that connectivity gives an inherent methodology of understanding how these mesh and node topologies connect together. And we will go with Zigbee technology. And here in Zigbee technologies, we have a global idea of how this frequency gets connected with. It is a 2.4 GHz global frequency, where with a data rate of 20 to 250 kilobits per second, with a range of 10 to 100 meter per row, and it always supports a mesh and a star topology. So generically, a mesh and a star topology is a nodal connectivity in a design where the maximum nodes up to 65,000 per network is connected to create a wide area network, and with a security alert of 128 encryption, 128 encrypted security alert system with a profile of very low multi-year battery life for it. And Zigbee, it is IEEE 802.15.4 mesh networking standard. That is, Zigbee builds a self-healing wireless mesh where each powered node acts as a router, relaying data for its neighbors. Moreover, designed for very low data rates and years of battery life on coin cells. So these are Zigbee, and Zigbee builds a self-healing wireless mesh where each powered node acts as a router, relaying data for its neighbors. Designed for a very low data rates and years of battery life on coin cells. And this Zigbee nature creates a reliable set of connectivity systems, that is router systems, battery systems, and things that are connected together to create a self-healing wireless mesh network, each creating a powerful reliable network. Zigbee in the real world. The large scale mesh sensing where wires are not practical, that is it is just anatomy. The Philips tube, that is smart lighting, consumer smart house. So each hue bulb is a Zigbee router. The huge bridge is the network coordinators, bulbs relay commands hop by hoop across the house, letting a signal reach rooms far beyond a single radio's range, no extra wiring or Wi-Fi congestion, and all these things are there. And here we have a Amazon Smart Plug, Smart Things, Ecobee, and many industrial sensor deployments like Groker. Water utilities use same Zigbee mesh principle at a scale, and how all these things are used is it coordinates how the mesh self heals us, coordinates, forms the networks. It is assigned with 16-bit PAN ID and channel 2.4 GHz with the routers extended coverage. That is main powers devices like bulbs, plugs, relays for frames by hop-on-hop method, and route discovery, that is ADAV based. If a router fails, the neighbor discover an alternate path automatically, because the nodes are connected together, one and around here and all, for all these things, followed by all these things, and followed by end devices sleep, that is battery sensors wake prime preferably to transmit, then return to deep sleep. So this is a battery backup type, where a battery backup type creates more backup innovative ideas, that is that deploys a battery sensor wave, where these deploys are created, enhanced, and processed, and accumulated by the method of in device sleeps. And in this we have a big global vision of understanding the idea of how these things work together, and how these principles work together. So overall, the principal thing that works is through the reliable method of understanding the methodology and the ideology of end device sleep cycle. And this methodology and ideology of end device sleep cycle creates a quite bigger amount of data set to move on with, and these data sets would create a complete ecosystem for developing various process of information, as well as various iconic feature extractions for this in-device sleep method. And we will work on with this in even more further videos to identify the short range protocol. Thank you.